Is there? Okay.
Now your countdown starts.
Yeah, yes, sir. Thank you. So as sir had made a good, enthusiastic and energetic start to post-lunch session, which was very important actually, I would like to extend my warm welcome to all of you and thanks to the organizers, to the esteemed guests, and as a fraternity all coming together for this kind of sessions which continued for years together. I think this is a great engagement platform where we can discuss a lot of new things which are developmental in nature, which are something we learn from each other, from the experiences, and we take it into our daily lives of working again. So my topic today is around boiler house, of which relates to what we are doing, that is in boiler house around safety and efficiency, which is your ongoing thing, and something which is from sustainability point of view and sustenance point of view. So there is an aspect of green, there is an aspect of what we can do to the present system, and there is an aspect of how do we develop SOPs so that we run the systems better. So it's going to be quite generic, it's not going to be very technical hardcore, but generic around what are the new things that we as an organization, as a boiler manufacturer, as somebody who works in the field of complete thermal circuit is bringing to the market. I'll be presenting that. So let us look at some of the key drivers of efficient steam generation system and overall steam system. So I would consider safety as the first pivotal part. Safety, which is an integral part by design as a part of engineering, and safety which is as a part of diagnostics and controls, which is to be built into the system, because human life and life of equipment both is important. Human life is important because it's somebody, a skilled person who is working in the plant, running the plant, the show, and the equipment, because otherwise if it falls down then the productivity goes down. So safety in design incorporation is an important concept which will keep driving our complete designs, and all our boilers we are also making in similar way. Economics and competitiveness, this calls more from the output point of view in terms of steam cost, and this will predominantly be around operating cost. So that's another important part. Innovation in combustion. I mean, this is an important thing. Though we used to relate ourselves directly in terms of efficiency to direct efficiency, which is a result of heat exchanger design, or an indirect efficiency, which is 100 minus all the losses as per BS 845. There is another aspect that the fuels should be fully combust, the carbon should be fully combust. So we have developed technologies at our ends which are greater than 95% in combustion efficiency, and this results into a much cleaner boiler operation. NOx levels is another important part, which is also an innovation that is required in combustion, so that we have more lower NOx producing systems going forward. Fourth important aspect which will be driving is the monitoring and the control aspect. So just not making good machine is enough, but to monitor it and to run it efficiently in terms of SOPs, that is depending on various types of reasons in the factory, whether it is capacity utilization or whether it is because of the product mix changing, is very important. So monitoring and control is another important driver. And then finally, the buzzword of sustainability and clean energy. Looking into what we need to do to the planet is give a very sustainable solution going forward. Most of the corporates now internationally and even domestically are slowly moving towards a sustainable kind of activity in everything, whether it is a supply chain, whether it is fuel circuit, whether it is the raw material that they are getting. So overall sustainability is a very important concept, and as a company and as a fraternity we need to look into sustainable action that is required to run a boiler house efficiently, and sustainable solution in terms of burning of various types of fuels which are non-hazardous to atmosphere. Less of fossil and less of non-hazardous. Now I'm bringing this aspect again because cost competitiveness is one important aspect. In last 2 years, there has been quite a change in terms of fuel prices. In last 5 years, we see almost 25 to 50% increase in terms of steam cost per kg. I've just put a synopsis. The fuel prices may differ from area to area. There is a lot of changes that has happened, but a broad mota-moti thing is that 25 to 50% is something that the rise has happened over the period of 5 years. This drives everything around, because in a market which is highly competitive in terms of so many players coming in, every amount of money saved will depend a lot into what kind of technology is producing it and how do we maintain the system well. So this is a it's a physics diagram. Actually, it's a Sankey diagram of the complete steam and condensate loop that exists in any industry plant. So the total amount of 100% energy input that goes to boiler as an input comes out as an 80% as an energy which can go into the process, of which 16% is lost in the flue gas, which is the exhaust, that is the main loss that happens in the boiler. Then the radiation loss, which can be as a result of design and also as a result of capacity utilization, because it's an indirect relationship, and the blowdown losses. This 80% further, when it gets distributed to the utilization area, then we'll see the further losses which happens in distribution is amounting to around 2 to 3, and between condensate and flash it is around 16%, 8 each we are saying, which is recoverable. So overall we are saying around 60% is what goes to the user. Now this heat, once this complete heat is utilized, the balance heat should return back to the system. So the overall idea is that the complete heat circuit is important. I am just stressing this point because it's not just the generation, but generation, distribution, utilization, recovery is a complete cycle, because at the end of the day, if the recovery is good, it actually increases your steam to fuel ratio, because it helps in increasing your feed water temperature and steam output actually, not S2F, but the steam output. Now, there are some myths that just buying an efficient boiler will resolve all the issues and then we'll get a high efficiency. It's just like that. Boilers do not operate at rated efficiency. We have to understand there are various factors. Capacity utilization is one factor. Input in terms of fuel is one of the factor. Seasonal changes of production is another factor which impacts. So we have to understand all those things. Then mostly we have seen there is a difference between monitored to non-monitored system in the terms of 8 to 10% at least. That's the basic difference that we see. And the fuel bill actually is determined by what it is operating at what condition. So that's something, these are some of the myths which we will unravel as we go forward. And that we have to remember one thing, that the boiler initial capital cost is very low as compared to the overall life cycle OPEX cost. So running a boiler efficiently, there are a lot of things that needs to be done other than just buying a efficient system. So there are certain, we'll just go through very simple basics which most of you know, but still just to run through the factors affecting efficiency, like number of boiler passes. The higher the passes, the more amount of heat that the water gets. So a 2-pass boiler will be lesser efficient than a 3, lesser efficient than a 4 or a 5-pass, other than the external heat recovery in terms of an air preheater or an water economizer. Combustion system design, whether it is a solid fuel or whether it is an oil and gas fired boiler, it is very essential that the combustion system has got enough amount of automation so that the most amount of combustion efficiency happens. What we get is a thermal efficiency, which is a mechanical heat exchanger efficiency. Combustion efficiency is the efficiency which says that how much amount of the carbon is finally left in terms of unburnt. That's what is important. So like burners with ECR technology, electronic compound regulation, which is with separate servo motors for air and fuel, is a good combustion technology. If it's a solid fuel, then a progressive combustion where you will have the fuel and the grate moving with respect to each other and the fuel burns in a better way till the core is a better combustion efficiency. Then air to fuel ratio control, whether in terms of earlier we used to have cam based mechanisms to have air to fuel ratio. Now we have moved to electronic compound regulation plus oxygen trimming in many places to maintain a better air to fuel ratio. So efficiency depends very highly on that. Heat surface area, well, this is a known thing to everyone. There are many other design factors, like there are indirect losses which we need to have better inbuilt design so that the indirect losses can be managed in terms of like blowdown loss is there, radiation loss is there. And then the external heat recovery from the stack, which is the basic most huge amount of heat which goes away from the boiler. Now, whatever I said till now was more to the existing system and some of the new developments. But running there is always a barter between what we will get in future in terms of green and better technology versus the huge mass of boilers which already exist today and which are burning fuel. How do we run them efficiently in terms of a better asset management, and how do we have the best possible efficiency out of it? So there are two concepts. One is the asset care concept, in which we focus around that the asset uptime has to be always up, and there are 4 areas where we should look into. One is the area of energy efficiency, another is the area of O&M practices, one is the area of safety, and second is that once we get all the information around this area and the action points, how do we sustain them forward? So we can do it physically, we can do it digitally. So next few slides I'll speak around that. So these are the 4 areas. So safety is one very important area in the asset care, where all types of interlocks has to be studied from time to time so that any kind of a downtime plus accident can be prevented. Efficiency is one important parameter where direct efficiency and indirect efficiency should be monitored and all the points related to it. Environment is the point which is related to emissions. So it can be CO2, it can be NOx, it can be in terms of what is the waste coming out for a solid fuel boiler in terms of unburns. And operation and maintenance practices, which is inherent to the plant's own practices, and good engineering practices, which is required to be put for that system. So around these 4 areas is the asset care which is done physically, which we are doing as a organization, and which we also say to the fraternity that all should practice it. It's their own way. Every plant has its own manufacturing practices, but it has to be under some quality system, and it needs to be followed through with a proper review mechanism. So when we did an almost 800 to 1,000 customers survey some 3 years back, we found that 80% was the overall score, overall efficiency score in the 4 areas when it was put together. And then we decided that it's time when we have to look into physical and digital way, how do we sustain the complete system. Then the concept of sustenance started coming in. So these were some of the important parameters like steam flow, fuel flow. We all know this, the important parameters, which is boiler critical parameters which needs to be monitored. Once you have monitoring, you know that where the equipment is performing, then based on that you can think of that how do we establish a baseline where these points come in, the points like boiler efficiency, steam to fuel ratio, stack loss, blowdown loss. So indirect efficiency losses and the major safety part and the efficiency part, which then becomes your baseline data which you will be sustaining over a period of time by impacting through asset management and by through digital help. And last is the enterprise level KPI, which are at the plant level. So it can be steam to energy cost, it can be production cost, it can be plant uptime overall. So this is the way how we look into the boiler house from physically looking at asset care as one aspect, from asset care to a reactive service to a proactive service in terms of digitally sustaining it. This is the way forward for making the existing system run well and run them efficiently. Because everything once monitored, it comes on paper, and once it comes on paper, we take steps and actions to improve it. Now, just for a simple example, like the parameters of steam to fuel ratio, condensate recovery factor, boiler efficiency, feed water temperature, these are not static numbers, these are dynamic numbers, and these keep changing based on various conditions. The simple condition would be change of product mix while manufacturing. The simple thing for a beverage plant could be change in seasonality. So from summer, if it goes to rainy season, the load changes, the input parameters of fuel changes, a lot of things in this parameter changes. But your equipments are tuned to a particular setting which were at the peak time when it was designed. So once this data starts coming in, then we start taking the action. So this is just for a mimic, which actually shows there are various critical parameters like steam flow, pressure, fuel flow, IDFD settings, O2 settings. These all things keep fluctuating based on the condition of operation. And there are multiple of the factors. But our settings when we run and commission the system is based on a single setting. So if these are digitally monitored, then this can be sensibly set with respect to how the plant is requiring in terms of variety of changes that are happening. This is just a simple understanding in terms of various plants where we looked at all these parameters on the left hand side, the communication part, and the green actually symbolizes that it is uptime is good, the red symbolizes that there are some issues, and the yellow symbolizes that issues have been discovered but we don't know whether the issue is because of the fault in the system or what. So as simple things as rectifying a problem, looking into the uptime of the system, which parts are working or not working, and if they are working, are they calibrated and they are working to the fullest, we can actually take the system to a greater than 95% uptime, and we will see that the outcome of the system is more productive rather than what it used to be if it would have been only with a system on it. So with a system, with a sustenance service, we try to do all these things. Now this graph actually signifies the first part, the red part, is when we have it's a normal plant, where the plant is running. Say, take an example of a beverage plant, or take an example of a textile plant. We have a boiler, we have a steam system, the complete system is running, and we see that our energy lines are not so standard and not so specific. The plant is clear that mota-moti how much fuel is going, how much steam is consuming, but there is no direct correlation with respect to the production and the steam consumption. And once we install products on it which are right in time, whether it is an efficiency monitoring system, whether it is a metering system, whether it is any kind of condensate recovery system, or pressure reductions where pressure reductions were not there, we arrive to a situation where the plant starts performing in terms of better operational efficiency. Once that is done, we actually come to a point which is this green line where we establish the baseline. The baseline, once it is impacted, after that comes the digital part, where digitally we try to sustain the complete system by understanding how the variations are happening, why the variations are happening, what are the reasons, and when is the time variations are happening, and what is then the SOP and the action plan to be taken for that. So there is a complete cycle from an unattended system, unmonitored system, to a system where we equip it with right devices, and from that right devices we establish a baseline. From that baseline, how do we understand that the plant moves with respect to changes in various external factors, and then we not only reduce the variations. If you see at the right side blue, we don't only reduce the variations, but we also work out on the baseline. The earlier we try to better the baseline also. So overall, any kind of an asset, just by designing an asset in today's world won't help, because the market condition is very dynamic, production conditions are very dynamic. So the entire cycle needs to be sustained in terms of a complete monitored system. That's the whole purpose. Now this is an example of one of the customers in textile, where this is for a boiler house example, where we took an efficiency monitoring system which was put on the boiler, and we started looking at all the critical parameters. And after taking all the critical parameters, after setting the boiler tunings like ID, FD, other respective things in terms of feed water temperature, in terms of the fuel feed movement, we could record a saving of around 7%. Once this was done, then we took over the digital sustenance service, where we started looking at all those aspects in terms of whether each equipment is working, not working. If it is not working, what is the impact that is happening? Then settings of each and every aspects of the machine. And based on digital sustenance service, we were able to save further 3%. And then we have done renewal, and now we are understanding the system much more better with respect to production. We are able to correlate our equipment with respect to operations that is happening in production, and hence we are able to save more. So what I said initially was that though we will implement newer technologies, but existing system to make it operate better, there is first an equipment in the cycle, then there is a huge part of digitally sustaining and controlling the entire system. So this is the complete cycle which is new that we are bringing to the market now. And I'll ask one of my colleagues also to speak for 2 minutes once I finish the next slide. This is again some of the critical parameters more related to higher capacity and a power boiler. So same way for condensate recovery. For condensate recovery also, I think, Dhruval, you want to add this? This is a ultra denim textile case. Maybe you can add for, you have the mic there? Oh, you won't have a mic. Later on? Okay. So in this case also, when we took the service initially for condensate recovery, the CRF was, condensate recovery factor of the plant was around 33%. Then we started working on it, and based on that we found that we were addressing some of the gaps in terms of equipment performance, in terms of motive team pressure to the pump. The pump was not working. We rectified it and we brought it to 43%. Then we further looked into it, and currently looking at the other aspects of the machine, we brought it up to 47. And slowly we saw that we could take the improvement to the benchmark level of 55, which is expected from that kind of a plant. We are sustaining it and we are growing it. So overall what I am saying is, while we recover the highest amount of condensate, that condensate goes back to feed water tank, and it increases feed water temperature, and it impacts the efficiency of the boiler also. So every 6 degree rise in feed water temperature increases efficiency by 1%. So I'm trying to bring into logic that the entire steam circuit is very critical. And in entire steam circuit, when we look at from a point of view as an holistic overall system, and we operate around the equipment by operating, looking at each of its critical parameters, the overall system efficiency is increased. So at Force Marshal at present, we are doing it for different equipments. We have moved away from equipment to plant level, and we are trying to see that we sustain the system and we start growing it. By doing this, 3-4 important factors are addressed. One is that the system uptime is always up. Second important part is system runs operationally very good in terms of different types of production scenarios. And another important part is by doing all this, you are not only reducing fuel, and hence you are reducing steam consumption, you are actually benefiting the nature also in terms of more amount of waste heat going out, in amount of lesser usage of fuel, in amount of the plant actually earning more by saving more. So if we try to sum it up in terms of last 3 important points, in terms of sustainable boiler operations and environment, so I would say that we are looking forward to guiding all the plants in terms of usage of renewable energy, clean and efficient renewable energy, which is fully progression combustion technology. So we are working on technologies of multi-fuels in a single boiler, 3-4 different types of fuels. We are also working on multi-utility together in terms of steam, thermic fluid, hot air, and some of the hybrid technologies. And we have seen that the efficiencies of the systems are very high. The end customer benefits over a longer life cycle of the plant, where he has much broader horizon of fuels which he can burn. Second is designing lower NOx and CO emission technology systems. Our oil and gas fired boiler and biomass boilers have a larger surface area, because of which it enables to a lower NOx. So lower NOx burners and lower NOx boilers. And third important point is that bringing the whole aspect of monitoring, digitally sustaining, and base our go-to action points on actual operation of the plants with respect to the production system. So overall, 3 things is that we should look not only boiler as a boiler, but boiler as a system, because a lot of things have to return back to the boiler. Second is looking to the system in terms of always able to know what is happening with the system in real time, and not in terms of what is a written efficiency, but a real-time efficiency and a real-time system performance. When we combine this together, we see a very efficient system. Hence, in the beginning, I had written that it is boiler efficiency and safety, which goes hand in hand, and sustainability and sustenance, which goes hand in hand. So that's the overall thing I wanted to just share with you all. Maybe more we will see about the greener technologies as we proceed. Thank you.
Thank you for completing your speech within prescribed time.
Thank you.
Now, second topic of this session is green fuels. And that is green fuels topic is the heart of this conference. Now, I will invite the speaker, who is not require any identity, because he is known by his own appearance and look. So I will not tell his name, but he is well known by his appearance.
That's why I am not going to change my entity. Okay. First of all, thank you very much, Saket, for inviting me as a speaker or for this presentation after post-lunch session. Normally, they are inviting me in that session only. So that at the last I am seeing many of the R's are taking a good advantage of that. So, and now the topic, from morning we are seeing everyone is deliberating on the green fuel or green technology or green sustainability, everything. So everything depends when we are talking about the steam generation or the power generation. Everything depends on what is the main thing? Main thing is the fuel, right? When we are talking about the generation, whether it is steam to process requirement or power requirement, main is the fuel. So now in last scenarios we are seeing the industrialist or we ourselves engineers, managers are in very much dilemma. Okay, what to do? One side the fuel costs are rising, one side industrial pressure or production cost and everything, too much pressure on all the sides. So we were trying to cut down where we have to cut down. A single rupee now is very important. Earlier days when we were working, at that time nobody was asking about the what is the steam fuel ratio, what is the efficiency, everything. Nobody was asking at that time. Because that time things were different and the cost of fuel was not that much high or that much not considerable with respect to the production cost in terms of money. But now when this fuel prices are going day by day, and again, not only the price, but we have to go with the environment-free fuel only. Now the day will come, we have not to use any other fuel which will not sustain, which will not protect the environment. So, looking to this, why green fuel, the future of boilers? Why? Right? Because as I told, okay, now earlier we were talking about the SPM, means particulate matters, SOx, NOx. Now we all acquaint with these all things, and we have already controlled everything. But the now next term is what is coming? CO2 reduction. Now everybody wants the CO2 reduction. How to reduce CO2? Right? Now three earlier, PM, NOx and SOx, gone. Right? We have controlled, we have managed, anyhow we are trying to control everything as per the norms, and norms are also tightening now. Earlier what norms we are maintained, now what we are maintaining is totally different, even though we are maintaining. By adding the cost, right? By adding the cost, આપણે પૈસા ખર્ચીને પણ ESP લગાડવું પડશે, વેટ સ્ક્રબર લગાડીએ છીએ અને કરીએ છીએ. કેમ કરીએ છીએ? આપણું પ્રાઇસ વધતું જ જાય છે, સ્ટીમની કોસ્ટ વધતી જ જાય છે. જે આપણે 1000 રૂપિયા 1500 રૂપિયાથી આજે 2000 2500 રૂપિયા થઈ ગઈ, તોય આપણે કરવું પડે. શું કરો? તો સેમ હવે આપણે CO2 રિડક્શન માટે કરવું પડશે. તો CO2 રિડક્શન માટે શું રહ્યું? કોલ તો તમે યુઝ કરશો તો CO2 વધવાનું જ છે. સો ધેન ધીસ green fuel is compulsion or must in the future, right? So mainly green fuels are the better cost saving to replace the FO. Even coal also, firewood, burning a biomass briquette as per most efficient than the burning of FO, firewood or coal, because it provides more calorific value per kg and save great amount on boiler fuel cost. At the same time, it is a pollution-free and eco-friendly fuel. The main thing is this. Even with the cost also, we have to see pollution-free and eco-friendly fuel. That is our main requirement now. In other way, we can say, even the cost is there, we have to go for the pollution-free fuel only, right? So, number of companies in India switched over. Some were switched over, some were blending, some were started, some were checking the design a different way. But now it is must to, we have to think for, we have to use the green fuel only. Then demand of the green fuel are also day by day going higher and higher. Technologies also were coming, production also were coming. We have to, because the biomass, handling of the biomass from one place to another place, it is very difficult. But handling of this now, it is going to be very, pellet, briquette is very easy, and transportation cost also very low. We cannot transport wheat, paddy or from the northern region to Gujarat. No, but we can transport the briquette or pellet from their place to here. So now all these technologies now coming up and the production also going higher and higher. We have to think for this use of the green fuel. Now this is important slide for everyone. Green fuel. This is the future pizzas for boiler, right? આપણે જ્યારે હતા ત્યારે આપણે પિઝાની વાતો નથી થતી, અમારા ટાઈમની વાતો કરીએ. આજે તમારા ટાઈમની વાતો કરીએ તો પિઝાની જ વાત થાય. એટલે આપણે પિઝા હવે કમ્પલસરી કરવું પડશે, ખવડાવવું પડશે બોઇલરને. તો પિઝામાં શું શું ખવડાવી શકીએ આપણે? બોઇલરને પિઝામાં શું ખવડાવી શકીએ? આટલી બધી વસ્તુ ખવડાવી શકીએ, બરાબર? એના પ્રમાણે બોઇલરને આપણે ડાયજેસ્ટ કરી શકીએ એ રીતે એને તૈયાર કરવું પડે. તો વન ઇઝ ધ wood, pellets, rice husk, IDF and SRF, right? That is the municipal waste. Even corn cobs, જે આપણે ક્યારે વિચાર્યું ના હોય કે આ બધી વસ્તુ પણ આપણે ખવડાવી શકીએ. કોર્ન કોબ્સ, બરાબર, કોલ તો છે જ, ઇવન લોઅર જીસીવી કોલ ઓલ્સો વી કેન make it in the form of mixing with the other briquette or pellets and make it as a good fuel instead of using directly. Then plant-based, then cassava. Cassava is also roots of some these vegetables, trees. That also a good fuel for this, even ethanol also this making out of that cassava roots. Then briquettes of all kinds of woods, even waste, agro waste, and this even we can say paddy waste or this, all these things. And wooden waste of any kind, that all makes a green fuel now for future, right? Already we have started and we are now going on a large way to start and starting consumption. But the main thing is that we have to make our boiler, because it is not like easy to use all these fuels together or alone, but we have to make it as per requirement, as per availability, 10%, 20% blending, 30% blending, whatever the capacity, whatever the availability is there, we have to start using of the green fuel to survive against the pollution in upcoming days. So this is the biomass fuel. Again, what are the biomass fuels available? White wood, we can say that already briquette. Then forest residue also, we can make it as a briquette. Agriculture waste, municipal waste, already we have talked about. Then industrial waste also, we can make it compost, make it in the briquette form, pellet form, and maybe easily useful to the sources wherever available and utilize. Then there are number of processes for biomass fuel, biochemical process, then biomass compression process, product concentration, and thermochemical process. See, all this, by this all, making this all processes, we can make it utilize, make it transport from one place to another place easily, and converts into the bioproducts for the markets, right? As I told, as such, biomass, using a biomass, because the volumetric, the availability of the agriculture waste or anything, that is not being transport and not viable to transport. If it is viable only within a 50-kilometer range only, after that it is not going to be viable. So making it, processing this, all these things, agriculture waste or all these things, we have to process and then utilize. That will reduce a cost and making it a viable things. Government also coming up with the schemes, because without government initiation, there is very, very less chances of adoption of the things. So government also taking an initiation in manufacturing of the briquettes and pellets and promotion to the biomass based cogeneration industries, right? Why government is giving? Government is also saying that by now we have to account with the pollution-free, environment-free fuel only. So we have to, they have started the initiation, and the program provides that Central Financial Assistance, CFA, to project developed and services charges to implement the agencies, inspection agencies in respect of setting up of briquette or pellet manufacturing plants. See, first manufacturing, that is more important. Plants and biomass cogeneration projects in industry for these two sectors, because once manufacturers are also not coming, even though we are not getting utilization, availability is not there, then how we can use the things. So first we have to make it available. So for that also government also taking the initiation, because earlier days we were not finding out the briquette manufacturer, much briquette, but now we are seeing that a lot of briquette manufacturers, pellet manufacturers are coming up due to this, all these reasons. So financial assistance available under the program is as follow: briquette oblique pellet manufacturer plants rupees 9 lakhs per metric ton per hour. That is the manufacturing capacity. They are giving the maximum CFA of up to 45 lakhs per plant. Similarly, biogas cogeneration projects, They are offering this rupees 40 lakhs per megawatt and maximum up to rupees 5 crore per project. These are the all incentive we can say, or the initiation we can say by the government itself to promote these green fuels. Again, this biomass, different type of this garbage, alcohol fuels, crops, woods, landfill gases, all these are of the types of biomass only. Now we can compare why this, what is the difference between or comparison between coal and biomass fuel, right? Efficiency wise, we can say high ignition point, hard to ignite, high volatile, high burning efficiency, easy to burn, or little carbon residue. So main thing is the little carbon residue. Carbon is very less. That is only the biggest advantage for this green fuel or biomass fuel we can say. Volume, high volume, large storage space required, high transportation cost. Compressed volume, save space, easy to transport, right? When we are briquetting, it is being compressed and pellets also being compressed, so it is easy to transport also. Then environment effect, generate SOx and P2O5 and gases of acid run. In this, no SO2. Mainly, SOx is nil because all this briquette and all this having a very low SOx. So that is one thing we can not having any issue with the environment friendly. Now type of biomass fuel again, wood, woody fuels, wood waste, all types of excellent biomass fuels and can be used in a wide variety of biomass technology. Forest residue, mill residue, agriculture residue, urban wood and yard waste, dedicated biomass crops. Even now farmers are also started to grow dedicated biomass crops, means we can convert into the briquettes dedicatedly, which are having a good value rather than the other agriculture products. So chemical recovery fuels and animal waste. Animal waste also now good briquetting in between, means mixing or blending for briquetting. So these are some photos for these fuels. You remember woody fuels, any kind of wood, wastage of wood after sawmill or cutters or like that. Then forest residue, right? Use forest residue. We are seeing that in forest there are burning, lot of burning. But if we utilize that forest residue, it's a good fuel. But we have to do briquetting or pelleting only. Then mill residue. Then agriculture residue. Agriculture means rice straw, wheat straw, all these straws, mustard straw. All these straws earlier we were using as a burning, right? Parali burning like that. So now we are utilizing as a fuel. On one side, in Punjab, Haryana, northern region, we are burning these paralis, right? But now what they are doing? Now they are not burning. Now they are making as a fuel and good money out of that, making it a briquettes, right? And ethanol now it is coming up with this thing. Now this urban yard and wood yard waste, that is the furniture waste or any kind of waste, we can convert into the biomass fuel as a burning in the boiler. Then animal waste, that is also in older days we were depending on this animal waste only, but now it being not used in the farmers or the villages, but we have to make it convert for the briquetting and pelleting also, and good amount of energy available out of that. Then dedicated biomass crop, as I told, it is only for this fuel to convert it into the fuel only. That is a good initiation taken by the farmers also to make it as a fuel. Then type of pellet also, as like a briquette, we have to convert it into the pellet also. Pellet is of a smaller size and briquette is of a bigger size. That is only the difference, but we can use both the ways in the boiler for this firing. Then rice husk, bamboo dust, right? And this penny shell, these all are wood chips. These all are the types of fuels available, and nowadays the market demand is also going higher and high, and utilization point of view also increasing. Again, this type of pellets, out of that, what are the sources and making the pellets? Bushes, grass, Even grass also, what we are throwing and making it a, right? Cutting off grass and making it as a, using as a fuel, it is also having good energy or good fuel. Leaves, then corn cobs, as I told, rice husk, sawdust, wheat bran, and wood shavings. These all are the product for this biofuel or briquettes, you can say. What is biomass briquette now? Now we are talking about the briquettes. What is the biomass briquette? Biomass briquette are the biofuel substitute made of biodegradable green waste with lower emission of greenhouse gases and carbon dioxide. Right? That is the main thing to reduce the carbon dioxide in the atmosphere. Then traditional fuel sources with respect to what fuel we are using as a coal or oil or gas. This fuel source is used as an alternate for harmful biofuels. The briquettes are fired with coal in order to create the heat supplied to the boiler. Biomass briquettes are built from recycled green waste, producing less greenhouse gas emission because of the matter has already completed part of the carbon. Again, I am saying that it is not possible to use to 100% briquette because the quantity, availability, again a factor. So we have to try to blend with the coal, whatever the quantity, wherever the possibility, to reduce the CO2 emission in the atmosphere. See, these are the briquettes, different briquettes with the different sources. In Gujarat, there are different sources of the briquette availability because we are having a groundnut shell. But in MP, if you go, it is a mustard. If Rajasthan, you go wheat straw or the rice straw. So in the different regions, the availability depends on the agricultural areas where we can make it as a briquette. And we can transport it easily one place to other place once it comes in the form of briquette. So sawdust briquette we can see only near to the forest where this wooden or cutting show mills or like that, in that area only. If we think of the show mill, this sawdust in other area, it is not possible. So depends on the area's availability, we have to use the briquette or we have to manufacture or process the briquettes. Then sawdust mixture, then shredded straw briquette, then shredded paper briquette, means paper mill waste, means paper waste also we can process into the briquette. But again, the quantity and availability are very less. Then MDF briquettes, pine briquettes, mahogany briquettes, that is also one form of these trees. Then cardboard briquettes. These all are the form of briquettes. Biomass briquette again, this shape and different sizes. Even with the charcoal also we can form a, charcoal means half burnt fuel, this wooden, we can make it as a briquette. Round briquette, hexagonal shape, cube shape, that is the one briquette shape also. Now, biomass briquette specification. Size is 90 mm dia with 3 to 12 inch mixed length. Then
Hello.
PCV is 3800.
I request you to brief.
Okay, now fast. 3800 to 4300 kilocalorie. Moisture is 5 to 8%. S is 4 to 9%. Volatile metal 55 to 65. High volatile matter and sulfur is less than 0.5. Carbon is very less. See, 70 to 20% carbon. That is the main advantage of this green fuel or biomass fuel. Then applications in all industries now, with the smaller capacity or the medium capacity boilers, we can use this. This I am not taking. The boiler where we can easily burn in the FBC boiler also with this type of arrangement and with this type of arrangement. Both the arrangements we can burn the fuel easily. Right? But there are some limitations also with the burning of the briquette. That also we have to take into account. We have not to directly, it is not like a good fuel, so we can burn like that only, but it is again some issues with the burning of these briquettes or pellets. Airflow, we need airflow, because whenever this fuel is burning, the whole due to the ash, the impurities of ash or the salts or this sodium or this all impurities in the fuel makes it the grate bar holes or the nozzles getting choked and insufficient air, again creating an issue to the boiler. Then ash removal is also, because ash is little bit sticky due to this, and clinker formation is also high. So FBC we have to take care while burning of this type of fuels. There may be chances of clinkerization, so we have to take care. And last one is that fouling. It is having a fouling characteristic. Any such type of fuel having a fouling characteristic, so we have not to like that we have to burn fuel, but we have to make it cleaning arrangement, soot blowers, all everything. Right? Thank you very much. Thank you.